Hello, Calhounians. Here's your next set of notes. 4-2, angle relationships and triangles. The objective is by the end of class today, I'll be able to find missing angles from the interior or exterior of a triangle. Using properties of triangles, I'll be able to solve equations using triangle properties. Underline those terms. Let's take a real quick look at the triangle sum theorem. Box in that number 180. Put a bunch of stars by there. Let's Shipley remind us.
Hey Shipley, if all the angles of a triangle have to add up to 180 all the time, give me 5. There we go. See, Shipley knows.
That's such an important thing to remember, guys. You need to be thinking triangle 180, triangle 180. All the interior angles of a triangle must add up to 180 all the time. Box in that second 182. We got some stars, we got some boxes. Y'all are not going to forget that. Example 1 is going to be straight up review from our last set of notes. There is nothing new here. We're going to write and solve an equation based on the triangle sum theorem. For example 2, we're going to actually do a little bit of algebra, but the algebra itself should be really easy, especially considering the fact that we've solved a bunch of triangle-based equations already. Label our diagram, write and solve an equation. For part B and C, we're going to plug in the value we find for x, and that's that. Should be easy. Next page, we're going to get down some very basic vocabulary that we've seen before. Complementary and supplementary. Take a second to get those down and note that all the angles of a triangle have to be supplementary. Pause the video, make it happen. On example 3, all we're doing is filling in some missing angles of a triangle. And if we remember the triangle sum theorem, the 180 theorem, this should be very, very easy. I'm going to get the measure of angle NKM by simply subtracting two values from 180. It should be very, very clear how we're getting the values we're getting. 180 minus 88, minus 48 gives us what's left over, S44. On part B, to find that angle, JKL, all we got to do is realize that in the middle of that figure, we are dealing with supplementary angles. I know I'm calling it a linear pair. It's actually wrong because there are 3 angles, not 2, so it's not a pair. But the idea is the same. Let's do 180 minus 104 minus 44 to get 32 degrees. Next definition is equiangular triangle, which is exactly what it sounds like. All 3 angles in the triangle are the same. And since we know that all the angles of a triangle have to add up to 180, that means we just divide by 3 and get 60 degrees for each angle. Now let's put this knowledge to use. If I have an equiangular triangle where one of the angles can be considered 2x plus 20, the easy equation I can write is that 2x plus 20 equals 60, because I know if all 3 angles are 180 and all 3 angles are the same, each one of those angles is going to measure 60 degrees. So write and solve a very simple equation, get our value of x, and we're good to go. Y'all are going to do example 5 by yourselves as a guided practice, and show me example 5 before I give you your homework tomorrow. It should be very easy.
Hello, Calhounians. I am currently on the campus of St. Mark's School of Texas in Dallas, walking to a debate round I'll be judging. And here's your next trivia question. Now, the nation of Germany, their leader is not called the president, but actually the chancellor. And the chancellor of Germany currently, who's been in office since 1995, is actually the first woman who's ever held the position. My question for you, what is her name? Who is the current chancellor of Germany? Think about it.
We've now got some brand new vocabulary. Let's get the definitions of interior angle, exterior angle, and remote interior angle down. Pause the video, make it happen. The only potentially confusing part of this is remote interior angles. Let's take one look at the definition. The interior angle not adjacent to the exterior. Make sure those 2 words are underlined. So if angle 4 is our exterior, the remote interior angles are going to be angle 1 and angle 2, the angles that are not adjacent to the exterior. In other words, not angle 3. Here's why that matters. The exterior angle theorem tells us that exterior angles are equal to the sum of the remote interior angles. In other words, angle 4 out here is going to be congruent to the sum of angle 1 and angle 2. We add up angle 1 and angle 2 to get angle 4. You're going to be tested on this, so let's practice. Example 7. What is the value of x? All we're going to have to do is say that that 128 degree angle on the outside, just like the theorem tells us, is going to be congruent to those 2 remote interior angles, which leads us to a very easy equation. Example 8 is going to work very much the same way. except our equation is going to be a little different, and the picture looks a little different too. In this equation, we're going to say that exterior angle of 126 is going to have the same value as those two angles added together. Connect those just like we did our first couple, which leads us to an equation that, although a little longer, is still very easy to solve and use. Example 9, you're going to do on your own as a guided practice. However, I will give you a little nudge in the right direction as far as what equation to write. It's going to take a little more work. You might actually need more space than the notes allow, but you should be okay. We're still using the exterior angle theorem. We're still setting the exterior angle equal to the sum of the remote interiors. So solve the equation yourself and answer part B as well. Last thing we're going to cover is a really simple rule, which says the acute angles of a right triangle are complementary, which makes a lot of sense, especially given the fact that all the angles have to add up to 180, and we know for a fact that our right angle equals 90. So those other two angles are going to have to equal 90 as well when put together. Label them as complementary. And now example 10. So easy. If I know that one acute angle in a right triangle is 22, what does the other acute angle measure? Draw you a diagram of a right triangle, labeling one of the acute angles 22 degrees, the other one is x. You should be able to figure out by now what equation this is going to allow us to solve. Do this one. Example 11 is going to be a bit of guided practice when you get to it. I want to see example 11 done when you get to class before I give your homework. The good news is it's really easy. That's it for these notes. Bring these to get your points. Take care of business. Yeah. See ya.